Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about some additional relational algebra operations other than the basic union, set difference and the selection and project operation. So today we will discuss that what is the set intersection operation, what are the division operation, what is the assignment operation, and we will solve examples to see that what are the uses of this type of operations. First, we will start with the set intersection operation. The set intersection operation gives us that what is common between two or more relations. So first we need to consider two relations and then we can get the common attribute and values of the relation they are having matching. So when we are talking about a set intersection, that is exactly equals to two set difference operations. Say suppose we have two operations or relations R and S. So we can say this is the intersection operation representation by an inverted U. So here we can see first we are performing the set difference operation on relation R and S. So to give that what is present in S but not present in R. Now subtracting that from R will give us the same result that is being only there in R and also there in S. So the common attributes on R and S will be the result of the set intersection operation. So now let's see that how to perform the operation. Here we have two relations lone and lone1 and both of them has the branch name attribute. So by intersecting these two relations with the branch name attribute, we can have the common values of the branch name that exist both in lone and lone1 relation. Say suppose the lone relation have Tyler, Watson and Perry, these three names, and lone one has only Tyler and Perry. So our result of this set intersection will definitely be Tyler and Perry. Now we have to keep in mind that whatever is the number of times the branch names, the values of the branch names are repeated in both of the relation, it will be considered only once while we are performing the set intersection operation. So it will give the unique result of the branch name while we are performing this set intersection operation on the relation lone and lone1. Our next type of operation that we will perform today is the natural join operation. The natural join operation is very similar to the Cartesian product operation that we have discussed in the fundamental operation of relational algebra. Now, after that we know what is a Cartesian product, that is all the possible combination of the attributes or the relations that are being performed on the Cartesian product. So we can say that the Cartesian product are having the values that are both present in the relation left and the relation right, or even if the more relations are there. So now we can say that the lone and lone1, if we make a Cartesian product and then project some attributes on the relays, then we can say that we are having all the values of lone and lone1. Now, if we are performing a natural join on this operation or the relation on a Cartesian product, then we will have the exact same result on a Cartesian product. So how to write or represent a natural join operation? First, we will look at that. So this is our basic operation that we are projecting values of branch name, account type and customer name of the natural join of lone and lone1 relation. See here, this is the representation of a natural join in relational algebra. So first the Cartesian product on the loan and loan one will be done. Then we can select the branch name, account type and customer name from that. Now say we are having a more difficult operation on this. Suppose that we want that whenever there is a matching branch name on the loan relation, that is on the branch name relation on a loan one table, so that we can produce the result on a projection operation. So basically we are matching the two tables branch name and getting the result as a projection operation. So here we have to click on alias or renaming of the tables so that we can create and branch name matching on that. Or we can use the original table name followed by a dot and then the attribute name. Let's see how to do that. So this is the basic query we are having. Let us first look at what is the result of loan and loan one Cartesian product or natural join here. So that is the natural join of this query. Now we are performing this one, that is loan dot branch name equals to loan one dot branch name. Here we can see that this first result is from loan and this result is from loan one. So they are matching Tyler, Perry, Perry, but not matching this Perry with this one because it is coming first. So we have to first look in this relation and then we have to match it with this relation. So this Perry is not matched with Tyler, Perry is not matched with Tyler, and Perry is matched with Perry. So now this will be our resulting on the first hand relation of the output. So the desired output will look like on the first row is, see this Perry is being eliminated in our result. We are only having this relation because this Perry is being matched with this one. Our next one is Tyler. So now the Tyler is matched with this Tyler and then we will have the result and we don't have anything new in this relation and all the results of this one. So need to put it in our directly output. Now Watson will be not matched with this Tyler, Perry, and the Perry will be not again matched with this Tyler, but this Perry. So again, this Perry information will be directed to the output. Now we can say that we have naturally joined these two relations and then used to predicate using the selection operation of loan dot branch name equals to loan one dot branch name and then has the result of the branch name, account type and CS name on this particular relation. So in this way we can produce the natural join operation. Now we'll take another example different from this loan and loan one relation to enhance and understand the operation of a natural join more clearly. Here we are using three different relations. One is customer, account, and depositor. The customer has the customer name, their account number, and the corresponding city they live in. The account has account number, account type, and the remaining balance. And the depositor is a person who deposits an amount to a particular account. So it is the depositor name, account number, and amount. Say, in this depositor, the primary key is a combination of depositor name and account number. For account, it is account number, and for customer, it is customer name and account number to give the full identification. Now let us move on the natural join. If we natural join these three relations, so we can see that every relation has a unique value of each. So we can understand that what will be the exact value on a natural join. See, the natural join doesn't matter on the ordering. Say suppose we are saying so even if we first natural join customer and account and then the result with the depositor, it will be the exact same if we join the account and depositor first, then the result with the customer. So the resulting output table or relation will have the following attributes. I'm here naming only the attributes, not the values, because it will be long for this example. So this will be the resultant set of output or attributes that of the customer care and the account and the depositor natural join operation. So now we can have the customer name Adam, Eve, John and Mary with their account number and city with the account number that is matched with L16 Adam will be there, L19 Eve will be there, L13 John will be there, and the new account number will be added L8 but whose customer name will be missing in the natural join. Same as for this depositor will be joined with this result, and then L16, L19 and L13 will be there, and L3 will be added up in this natural join result because it is new, which have as a depositor name but doesn't got the customer name in the result. So by this way we can natural join all the results. Now if we perform on this natural join a projection operation with a select operation using a predicate that the customer name whose values of balance is greater than 40,000 and which have a loan account number, also they are living in the city of USNE. So now to define this query, we have to use a projection operation, a selection operation with the natural join operation. So let us see that how to write that. So this query will give us the result of the customer name, their account number and balance, whose city resides in US, the balance is greater than 30,000, the account type is loan, on from this natural join result on the three relations. So by this way we can use a composition operation of projection, selection and natural join. Now we will talk about another extension of the natural join that is known as theta join. Well, theta join is same as the natural join but is enhance the natural join by producing the selection as well as the Cartesian product in the same compositional operation. So we can write here we can see that we are giving the theta join representation first, that is a natural join and subscripting with the theta sign. Now we are producing that the selection theta is performed on the Cartesian product of the relation R and S. So that is more like a natural join, but as a relational extension that the selection can be done with the Cartesian product. So we actually has done all the theta joins on our previous examples. The next operation we will discuss today is a division operation. Division operation is more like that subtracting the value and then using a predicate on the subtracted value of the result. So first we need to produce the division sign operation and the result will be then inputted into some other sets of operation. So let us see that how to do that. Here we are using the customer name and account type from our natural join on customer and account relation, and then the result will be used as the division operator of the projection account type equals to loan. So let us take our example again. We are selecting the customer name and the account type on this customer and account natural join. Now upon the natural join, we will have the matching that L16, L19, L13, L12 and L8. But we don't have the L8's customer name. So it will be left blank in our natural join result. Now we have the result, so we are producing our formation on the division operation. So the division operation will be done first finding the account type equals to loan from the relation. So we will discard all the relation that have the savings account number or the savings account type. And then we will see that what will be the result of the natural join. After that, we will divide with the first projection operation. So the account type will be eliminated from the resultant result, that is consisting only the customer name that we are having from the customer and account natural join. So that is the basic use of the division operation. Now let us define the division operation more precisely. Say suppose R and S are two relations that is from two sets, that is capital R and capital S, so that R belongs to S. Now we can say that there exists a tuple T in every R and S if and only if So here we can see that the predicates are that the tuple exists in if and only if of all R and S, if it is in the set difference operation of these two sets R and S. So after eliminating S results from the R sets, then the tuple exists in the relation. And the second one is if we perform all the tuples that is exist in R and also in S, that will be the same of the tuples that exist in S on the S set. And the second one is if we have the R relation on the R minus S set difference operation, it will be all the tuples that we have as a result of the division operation. So now let us write more definedly that what is the division operation. So here we can see that R divided by S will be equals to, first we need to fetch the all tuples that exist not in S but in R in this R relation, and then subtracting the values of that we have a natural join or a Cartesian product with that value, and again subtracting it with all the tuples that existing in S along with exist in the difference operation of R minus S on this R relation, so that we can subtract the value from this R relation and we get the division operation result. So in this way we can perform the division operation to first fetch two projection operation, which can be a complex operation, and then the divided result will be the final output of us. Next, the resultant operation will be the assignment operation. An assignment operation is used to assign the result of an operation to a particular field or attribute in a relation. So let us see that how to look that. See, the last division operation we have done, we are using an assignment operator to first temporarily hold the initial individual values of the projection operation. Then using that operation of the assignment, we can have the actual result. So first, the projection operation of the set difference on relation R, we are performing and put it into a temporary variable temp1, and then using that temp1 with the natural join and Cartesian product with S relation, and then set differencing it with the common relation of R minus S and S, we are having the result temp2, and finally we are achieving the result by set differencing the temp1 relation and temp2 relation. So in this way, assignment operation is easier to make the operation looks very neat and clean, so that we are putting all the operations that are individual and complex to temporary variable, and then finally using the variable names to perform the final operation. So that are all the additional relational algebra operations. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.